next generation spacecraft, the Orion's Crew Exploration Vehicle. The sixth detailed test objective is called the Boundary Layer Transition, and it's gained a lot of media and public attention so far. Allard Butel went to one of NASA's shuttle processing hangars to get a closer look at this experiment.
31 seconds GMT.
We're in orbiter processing facility number 1 here at NASA's Kennedy Space Center, and that's the home to Space Shuttle Atlantis, where it's getting prepared for its upcoming mission to NASA's Hubble Space Telescope. I'm here with Ann Miklos. She is a project manager with United Space Alliance. That's NASA's main shuttle contractor. And Ann, you're going to walk us through an experiment we're going to be doing on Space Shuttle Discovery's mission, the boundary layer transition. What is exactly the boundary layer transition? First off, what are we talking about?
Well, boundary layer transition is an event that occurs every time an orbiter enters back in the Earth's atmosphere. Really, to better understand it, you need to understand what a boundary layer is. And a boundary layer is having a prop.
We are going to use the actual model instead of just the real shuttle.
As the orbiter comes in during entry, you have a nice, smooth, laminar flow that goes across the surface of the vehicle. But as the vehicle gets lower in the atmosphere, that smooth flow starts to kind of turn and become turbulent, causing some additional heating to the lower surface of the vehicle. So what this experiment's going to be doing is to actually be measuring that heat difference between the nice, smooth, laminar flow and the turbulent flow during the orbiter's entry.
So we're going to be intentionally disrupting that airflow underneath Discovery on reentry. Why would we do that?
It is something that occurs every mission. We go from that nice, smooth flow to the turbulent flow. But what we've done differently on Discovery is we actually installed a tile that has a 1/4 inch bump on it, protuberance, so it will intentionally trip the airflow from going from smooth to laminar to turbulent.
And I think you actually have
oh, we do.
One of the, it's just coincidence would have it. We happen to have the tile with that protuberance on it, that speed bump as we're calling it. Of course, every time you hold the tile or any kind of hardware, you of course have to have your gloves on. That's why I'm not touching it.
What this is the actual design of the protuberance tile as it was installed on Endeavour. You can see a 1/4 inch doesn't seem like that much of a height, but in turn this will trip the boundary layer a little bit sooner than the actual boundary layer will be tripped on the rest of the orbiter. Since this height is going to stay constant for the entire mission, we'll be able to have an exact profile of the heating that occurs from when the airflow goes over this tile.
And inside of it you've got sensors, and these sensors are like thermometers, basically.
Exactly. We have a little sensor that's, you can maybe just see it right at the edge there. That will measure the temperature of the airflow as it's just coming over the protuberance.
Now we thought, okay, it'd be great to have a model that's super, but why use a model when you can actually have a real spacecraft? And we do. And if you want to walk us through where the sensors are going to be and where the protuberance one is going to be. But how about the one that's farthest away, actually closest up towards the nose of the shuttle?
The one right there, that's a measurement that's kind of we're calling is our standard measurement. That one's just going to measure the flow before it gets to the actual protuberance or the speed bump tile. The speed bump tile, or the protuberance tile, is one that's marked in orange, which is directly overhead from you. And that's actually the location where the protuberance tile is installed on Endeavour. So from there, that 1/4 inch height will then create a wedge of heating that will go downstream of the protuberance. And the tiles that have the orange sim stock on it are the ones that have the temperature measuring devices or the thermocouples in it.
So we have a total of 10 that will be measuring it. One that's that's our control case with no disturbance ahead of it. The orange one where the actual speed bump is, and then the 8 behind it.
Right. If you think of a rock in a stream, and the water that's in front of the rock is nice and smooth, but once that water hits the rock and you look behind that rock, you kind of see a turbulent wedge of water that comes from behind that rock. And in this case, think of the protuberance tile as that rock. It's disturbing that flow, and what we're doing is measuring the heat loads that are aft of the protuberance.
Now, normally we don't want to ever do this. We typically go out of our way not to disrupt the airflow. Has this put the crew in any more danger, the astronauts, the shuttle in any more danger?
Absolutely not. This Flying this particular flight experiment is just as safe as if we didn't have the protuberance tile installed on the orbiter.
And our tests on the ground show that it would maybe only raise it about 15 to 20 degrees Fahrenheit, give or take?
Give or take, but the key thing is we're actually going to have flight data from this experiment, and that flight data is only going to better help our ground data with allowing us to be more accurately predict boundary layer transition.
And we're actually getting some help from the U.S. Navy on this, right?
We are. You're right. There is going to be a Navy aircraft with infrared sensing devices that will be actually taking pictures of the orbiter as it comes back down into the atmosphere.
And their designation is an NP3D Orion. I'm sure it's just a coincidence. They're Orion, our Orion.
It is.
Now NASA's thinking about we're going to do this on every flight that Discovery flies after this, right?
Exactly. Well, the plan is to always have a protuberance tile installed on each of the sequential missions on Discovery. The key is that what height the protuberance will be. Right now we're flying a 1/4 inch, and possibly next flow the goal is to possibly fly a 350 thousandths inch protuberance tile. So just about 100 thousandths higher than what the current tile is installed now.
Right.
So it will give us more heating parameters and more data for the scientific community.
Well, we're looking forward to the sts119's mission and the first of this test, and a great mission overall. All right.
Okay.
Ann Miklos, thank you very much for helping us
you
out.
very much.
Explain this. From Orbiter Processing Facility number 1, I'm Allard Butel.
This is Shuttle Launch Control.